Okay, so hi all, I'm back. I'm going to do some short introductory lab videos. So I'm kind of doing most of them all in one day, so you'll see me in the same place. But this is the anatomy lab, and so I'm here today in the anatomy lab that you would be in if you came to take the course in-house. And we have all these great models, of course, that you can't use this semester. So I'm hoping to show you a few of these models. So I'm going to go ahead and introduce you to, I'm going to try to follow along in your lab book so that I can stick to, again, the terms that you need to know for your lab book specifically. So in the very beginning of exercise 8, for the skeletal system, they introduce you to the gross anatomy of bones. And they start with just the classification of bones. They talk about some irregular bones. Those are easy, irregular shaped bones like your vertebra. They talk about some short bones. So I have some short bones here. If you look, like the carpals here, short bones. Tarsals here are going to be short bones as well. I can pull the foot up here. So again, tarsals, those will be some short bones as well. They go through long bones. Long bones are pretty easy. Long bones are going to be bones like your humerus, your ulna, and your radius. And then also in the legs, you've got your femur and your tibia and your fibula. So those are some examples of long bones, pretty easy. Sesamoid bone. So patella is probably the easiest of the sesamoid bones. And let's see if I can move my down so that you can see the patella there. Okay. So patella, your kneecap bone, right? And then, of course, they have the flat bones. And we'll go into more detail on the flat bones, especially the flat bones here of the skull, when we do the actual axial skeleton. So just really quick, those are just a quick, short way how to classify bones. Then they get into the different parts to the long bone. I don't have a model of this. And so if you look at page 90, they go through the parts of long bone pretty in depth here. And so you can see they're going to go through the epiphyses. So the epiphyses are going to be the distal and the proximal ends of the long bone. And then you're going to have the diaphysis. So this is going to be the shaft portion of the bone. They'll talk, let's see, I'm just going to go through your terms real quick. Articular cartilage is just going to be the cartilage that's going to be on the joint surface that's going to articulate with another bone. So you'll have articular cartilage there, right, to help prevent friction and damage to the bone. The red marrow, again, I can't show you. The red marrow will be inside, and if you look at your diagram, you'll see that it's going to show you where the spongy bone is. So you can look inside and see where the spongy bone is going to be, and in between those spaces will be your red marrow. And so you're going to have a lot of spongy bone in the epiphyses. So when you look in the epiphyses, you'll have lots of spongy bone. And then if you look in the diaphysis, you're going to have compact bone on the outsides, right? That compact bone is going to be solid, so it's going to have fewer spaces where, your spongy bone, you have the trabecula. It looks kind of like a sponge, right? So you want that solid compact bone to provide, right, the strength and rigidity that you need for the long bone on the outside there. And the inside is going to be the hollow medullary cavity. So the medullary cavity or medullary cavity, you'll hear it kind of called both. But that medullary cavity inside there is going to house what's called the yellow marrow, which is kind of like a fatty marrow. So that's what we call the yellow marrow. Let's see. Then we have the periosteum. So it's just going to be this connective tissue that surrounds the outside of the bone. And then you're going to have the endosteum, which is a connective tissue lining the inside of the bone and the medullary cavity. So you'll have endosteum inside here. So you can see all that in this diagram pretty well. It's a pretty nice diagram for you, and you can even color it in if you so choose. I think I covered all of the parts there that you need to know about. And if you have any questions, again, you can just always email me or send me a quick message through Canvas. So the histology of the bone is probably the most difficult, and mainly compact bone. So we don't have models of spongy bone, but when you look inside, again, a long bone, you'll see that spongy bone, and it's going to be filled with what we call trabeculae, which are like the lattices that form across the spongy bone. And then in the spaces between will be your red marrow. So, but we're going to go into, when we usually look at the histology of bone, we usually look at cross-sections of compact bone. And that's usually the most challenging. So when we look at compact bone tissue, again, the compact bone is going to be primarily found surrounding the medullary cavity of the long bone in the diaphysis, right? Mostly in the shaft. And when you look at compact bone, it's going to be organized into these cylindrical subunits. And this is what's usually most challenging for students when you're looking at like a cross-section. So I have this great model that basically here is as if we did a transverse cut, right? Transverse cut through the diaphysis of the long bone and are looking into the compact bone. And so if you were to take like a section, if you were to take like a transverse section to look at underneath the microscope, this is what it would look like. And you would have all of these, what we call these nice cylindrical subunits, organized subunits called osteons. So I'm going to try to give you a up close look at this. But if you look here, okay, so these cylindrical units here, these round units are called the osteons. And the nice part is they kind of blew them up and pulled them out here so that you could see the osteons pulled up. And so you'll see if you're looking at a cross-section of compact bone, it's filled with these cylindrical osteon units. They actually look like, it looks kind of like you took the cross-section through a tree, right? A tree stump, so they look at like all these big round tree stumps all stuck together, okay? So that's what an osteon is. And so an osteon is the whole unit, and it's going to be composed of all of these parts. So usually this is, for some reason, osteons are the most difficult for students to understand. And that's why I was hoping that maybe by showing you this model it might help. So first we're going to start off, and I'll just go through all of the parts that your lab book's going to go through. We have what's called the central, for each osteon. So each osteon here is going to have what's called the central canal. So, or you'll hear it called different names: osteonic canal, central canal, or also sometimes you hear it called the Haversian canal. So all three terms are correct. And that canal is going to carry blood vessels through there. So you'll see you've got some blood vessels. They're showing that here. Okay. And then surrounding that osteonic or central canal, it's going to be encircled by these like layers of matrix. And these layers of matrix, they're circles, right? They're literally these circles of matrix. They're kind of like the tree rings as you go out, right? Are going to be called the lamella, so, or lamellae for plural. So if you look here, each of these circular layers, I don't have a good pointer on me, but each of these circular layers moving out from that osteonic canal are called the lamella, or lamellae for plural. Then you also have what are called these perforating canals, or Volkmann's canals. And the perforating canals are the big ones. They're going to go, you'll see them, they'll actually go in between your osteons, like across your osteons. So these are going to be the Volkmann's canals. And then you'll see they'll connect the blood vessels that are running into what are called the central canals there. So the Volkmann canals, or the perforating canals, are going to be these ones. And you can see here, they don't show the blood vessels, they just show you the canals. So again, this would be like a central canal here, and then this is going to be the Volkmann's canal. So hopefully that, or perforating canals, either one, whichever term that you choose to use. Both are used. So then let's go back to the individual osteons, okay? So again, we have the central canal, or osteonic canal in the center. We have the rings of matrix called the lamellae. And these spaces right inside here, those spaces in the rings, are going to be called the lacuna, or lacunae again is the plural. And the lacuna is going to house the osteocytes. So these osteocytes are the actual bone cells, right? The osteocell. So osteocyte means bone cell. And what happens is these osteocytes, as bone is being made, okay, and being secreted, and at that point they're called osteoblasts, they secrete the bony matrix. And as they surround themselves in that bony matrix, once they're completely surrounded and trapped in the space called the lacuna, we call it an osteocyte. So inside the osteon here, these, and inside the lacuna, the spaces, again, lacuna is just the space. And then the osteocyte is the cell that lies in the space, in the lacuna. So hopefully that helps each cell. And those little extensions are a fun word called the canaliculi. And the canaliculi are going to extend from osteocyte to osteocyte across the lamella and the matrix, the lamella matrix here. And they will carry nutrients all the way from the blood vessel here, coming through the central canal, through the canaliculi to this osteocyte, through more canaliculi to this osteocyte, then through more canaliculi to this osteocyte. So the canaliculi are just going to be these cellular extensions that are coming off of the osteocytes that are going to be able to pass nutrients from one osteocyte to the next osteocyte through this bony matrix, the rings of bony matrix and the lamella. So hopefully that kind of helps clear up some of the histology of the bone. I am going to go through a slide of this as well, but I just wanted to show you this nice, great model. I feel like it's easier to understand on a nice big bony model like this. Okay, so I'm really quickly going to show you the slide of compact bone tissue. So that way then you can see what it would look like if you were actually looking underneath a microscope at a cross-section of the slide. So it's going to be very similar to looking at the models that we showed you that had the transverse cut. You're looking at a transverse cut into compact bone here. And so here you can see these are the osteons. Here's an osteon, here's an osteon. Those are those bone-forming units. And inside each osteon, you'll have the central canal or osteonic canal, or if you're an old-timer like me, you call it the Haversian canal. And so that's where your blood vessels are going to be running through. Then you have the rings of matrix here. So each of these big rings of matrix we call the lamellae, right? They're like the tree rings. So here's the lamella. Lamella is singular again, lamellae plural. So then inside the lamellae, you have these little spaces that are called the lacuna. So in your bone slides, your bone tissue slides, they just look like these little black spaces. So these little tiny black spaces are the lacuna, or lacunae if you're talking about the plural. And inside each lacuna would be an osteocyte in your living tissue. So each of these lacuna have an osteocyte in living tissue. So that's most of what you can see through here. Oh, these little lines here, these little tiny lines that are in between the matrix, they come out, they look like little black lines here going in between the lacuna, and those are going to be your canaliculi. So remember, the canaliculi are going to help to transport nutrients from one cell to the next. And they'll also connect again to the osteonic canal or a perforating canal if you have a perforating or Volkmann's canal going through there as well. So here's just a zoomed in version of this. You can really see a little bit more detail in this, and that you can see here's your osteonic canal. So this is zoomed in on just one single osteon here. And here's your central canal or osteonic canal. Here you can see are the rings of lamella. So here's a ring of lamella. Here's a ring of lamella. So you see these nice rings of the bony matrix that we call lamella. And then you see here's a lacuna. Oops, let me go back there, sorry. Here's a lacuna. And inside the lacuna are the osteocytes. And coming off of those osteocytes are these little extensions that we call the canaliculi. So you can actually see the canaliculi quite well here. And I believe that's it. This is just another model to show you the spaces, the lacuna. It might help after looking at the slide to look at this, but it's very similar to our models. Other than in this model, they actually draw in the canaliculi coming off of the osteocytes in the lacunas to show you what those canaliculi really would be doing. So again, they're carrying the nutrients from osteocyte to osteocyte through that bony matrix. So hopefully that will give you, these are just the pictures of the models that I had showed you before, and you can see again the perforating canals or the Volkmann's canal. And I think that's pretty much it. So hopefully that gives you a good orientation into bone. It was a little longer than I had intended, but that should do.